Hello again and welcome to this video. So in this video we're going to look at a LED with a button press, okay, with a microcontroller of course. So it's like once you press a button, the LED turns on, and when you press the same button again, the LED turns off. So let's get started by creating a new project. I'm going to call this, I'll just call it LED dash button, for simplicity. LED dash button, and I'll save it in our default location, that is under Proteus microcontroller circuits there. Next, and finish. Okay, so we can place our components. We're going to pick the PIC 16F877A, and also we pick the resistor. Let's just take the generic resistor. Capacitor, we also pick the generic capacitor. And then the LED, I'll take green. This LED green has a more appealing color. And then for our crystal, we take this one. What else we need? We need a button. So look for button. Take that one. Okay, so now we have all the components we need. So we are going to start placing them here, and we create a circuit. Okay, so we'll start with the microcontroller. Put it over here. Then we can put the crystal. Place it over here. Capacitors. Put here. Rotate. Put another capacitor here. Rotate. Just like that. So now this is the same connection as before. But remember, the microcontroller will still work for the purposes of simulation. It will still work even without these connections. Okay, so even if you ignore this part, it will work. It's only for the hardware part, like the physical hardware will not work without these connections. Okay, so even if I ignore the crystal, we still have a simulation. That's what I mean. So yeah, this is the same connection as before, rather in the previous circuit. And then we have a button over here. Okay, I'll just put a button there, and maybe rotate it as well to face that side. Then I also need a resistor for that button. Somewhere here I'll put a resistor and rotate it as well. Yeah, okay. Yeah, alright, so this is the circuit when it's completed. We have our crystal and the place between the two capacitors, the ceramic type capacitors, 22 nanofarad. Don't forget the ground. Now I've added a microcontroller power, the supply, the 5 volts to is normally the VSS or VDD, something like that. We only have one pin here for that power, so the physical microcontroller might be slightly different from what you see here. So there's a reset button. I've added a reset button, so each time you press here, you ground, and it's like the power goes off momentarily, and once you release the button, power goes back to the MCU. So it's more of a reset. Now this is a button to press in order to trigger the LED on or off. So This is the same arrangement as before. Connect the LED to a resistor of 33 ohms. And then for the button, we add a pull down resistor. We can give it a value of 1K or 10K. Yeah, so each time you press here, don't forget the power, the 5 volts to activate the switch. So since we are going to be sending a bit in here, so as our input we send a bit, and then for our output the bit is supposed to be sent out through the LED, so the LED will turn on. Okay, so let's head over to the program. Alright, so in our mikroC Pro, we're going to create a new project. I'll just go to File, a new project. So standard project, yes, next. Browse and place it somewhere. Let's see, this folder is already selected, so we are good to go. So I'll give the project the same name as the one I'm using in Proteus. So just to confirm, this is called LED button. So I'll also call this one LED button, just to avoid confusion. It doesn't have to have the same name, but just to be consistent, let's give it the same name. So select the same microcontroller, PIC16F877A, just like what we have here. Alright, device clock is set to this, so I'll leave it like that, and just click finish. Okay, so once we click finish, we should have something like that. So if I close this file, we don't need it. So yeah, that is what we have. We have the LED button. So I'll attempt to save this first so that I'm able to save my C file. So it should show LED button.c, so we save it. Okay, so again, just like before, we have the preprocessor directives there, and in here we should have within the main function we should have initialization routines, and also the other part would be, yes, main program logic. Yeah, like that. So those are the three parts we look at: initialization routines and main program logic are within the main function. Okay, so the main function acts like a gateway or an exit point or an entry point, whichever you want to call it. Without the main function, the program does not work, it doesn't do anything, it's just a code. So you have to add the main function, it's the one that does the execution. Okay, so right, so let's start with the preprocessor directives. We're going to define we'll say LED, and then put a space. So we define port B, that's where we have our switch and LED. So we define port B, bit F0. So that is the first bit to which our LED is connected. So yeah, we define the name. Okay, instead of using port B dot F0, we will be using the name LED. So that's what the define does. So we also define, we'll call this one switch, or better still, we can just call it button. We say button, and for button is port, still on port B, the second bit, which is F1. So those are our preprocessor directives. So we go to initialization. We set the trace register for port B. Bit 1, like the first bit, we just set it to this is a trace register, so just set trace B F0, so equals 0. Okay, so meaning we are setting that bit as an output bit, and then trace register B dot F1. So set this as input. Okay, so that is our button, where the button is connected. So we are setting it as input. And then the other part of the initialization is to set all pins on port B. We initialize them to low. So just say port B. So every bit. So we don't need to set dot something. This is every bit. So we send 0x00. Okay, so that it's not a capital X, it should be a small x, 00. So that sets everything to 0. Okay, so this is a hexadecimal number, but it initializes all the bits to 0 in port B. So we are done with our initialization routine. Okay, so for our main program logic, we start with the while loop. While 1, this is our endless loop, and then put that opening bracket. Then at the end you should have that closing bracket. So our program logic should sit between that while 1 loop. Alright, so now this is everything with our main program logic added. So within the while 1 loop, this is the scope of the while 1 loop. Remember, you should have an opening bracket and a closing bracket. So likewise here we have an if structure. It has an opening bracket and this closing bracket is down here. So this is a nested if structure because inside we have another if structure. So it spans from here to here. Okay, look at the opening bracket for this and the closing bracket is right there. Okay, so what happens is that if you press a button, so that is button, if button is equal to 1, this is active high, means we send in power, we don't ground, we send in power. We are going to look at the other scenario when the buttons are inverted. So active high, and then so we put a delay of 50 milliseconds to cater for the debounce. Okay. So what the debounce does is to confirm an actual switch press instead of any other mechanical disturbances. Okay, so if there are some mechanical disturbances, are going to be ignored. So we put that 50 millisecond delay, just a software delay, and then the second confirms if it's actually a button press. Then we toggle the state of the LED. So this symbol here is a bitwise not. It just switches between the states. So if the state was originally high, 1, it will just switch it to 0. If it was originally 0, it will just switch it to 1, like that. So that is what toggling means. And then the while structure at the end waits until the button is released. Okay, so that's what it does. So as long as the button is still pressed. So once we release the button, it's okay, nothing happens. Okay, this is just a wait. press is instantaneous. So yeah, that the program logic is fine. Simply click on build, and you should be having that. No errors. So Proteus, and simply double this and load the program. So look for LED button X. Change this to 8, and that should do it. Okay, so if we click the run button, we should have nothing to display until we press the button. So the LED turns on, turn off, it goes off, turn on, try to hit the reset. So if I hit the reset, that is what happens. Okay, so yeah, if I hit the reset, the program initializes. So yeah, then yeah, on like that, on and then off. Okay, okay, so in the next video I'm going to change this configuration a little bit, so that the LED should be activated when the pin is low, and also the button can trigger an input when this pin is also low. Yeah, so we'll see what the difference is going to be both on our hardware and software. Okay, see you soon.